Hi friends, myself Jeevita from KPR Institute of Engineering and Technology. Now I'm going to take a small topic in data structure that is called as kruskals algorithm. Actually, Kruskal algorithm was designed by Joseph Kruskal was an American mathematician, scientist and computer scientist. He was born in January 29 in 1928. At his time in the University of Chicago, Kruskal attended the Princeton University. He was completed his PhD in Maths in 1984. He died in September 19, 2010. Now shall we move to the topic of Kruskal's algorithm problem. First, actually, you want to know what is mean by algorithm. Algorithm is a step-by-step procedure to solve a given problem. So we need to solve step by step. That is called as algorithm. In Kruskal algorithm, we need to compute a minimal spanning tree of a weighted edge. Actually, minimal spanning tree means based on the minimum weight only we can solve this problem. Minimal spanning tree is the spanning tree connected undirected graph. Actually, if the minimum spanning tree based on the undirected graph, we want to calculate the weight. All the vertices together with minimum total weightage for its edge, and it always have v minus 1 edges. Actually, you have two types of graphs. One is directed graph and another one is undirected graph. If it is directed graph, there the direction is mentioned in the vertices. If vertices is round in shape and edge in the edge means two vertices have only one edge. In next slide, I'll show you. For example, consider here you have four vertices A, B, C, D. Here A to be connected with minimum weightage called as 2. And for B to D, the wedge is 5. And C to D, the edge is 3. Then A to C, the wedge is 2. And you have one more edge connected to B to C is 1. This is the graph I have shown. See, that is round shape in blue color. It is called as vertices, and both the vertices connected by a one single line. In that you have the number that is called as edge. So totally you have four vertices and you have five edges are there. So for Kruskal algorithm, we need to calculate the minimum spanning tree. You want to know what is mean by minimal spanning tree. So minimum spanning tree will always starts with smallest weightage and keep selecting the edges that does not form any circuit. This is the most important point in Kruskal algorithm. Suppose in any given graph, if the any circuit or loop is formed in the graph, then you should not calculate that edge or you should not select that edge. So here already I have told you have four vertices and five edges in this example. So we want to create an edge table and weight table. I have given the edge is equal to some five boxes I have given. For weight also I have given five boxes. So we have five edges. Our edge table will also contains five columns. In the next slide I have given now A to C, the weight is 2. And for A to B, the weight is 2. And for B to D, the weight is 5. Then C to D, the weight is 3. And one more edge is connected between B and C and the edge is 1. So here you want to see which one is minimum. So you want to take that minimum weight. So in all these five edges, we have one and only weight is one that is connected between B and C vertices. Now you have to put edge and weight column in. Take it the edge as BC and mark it as 1 in the tabular column. Next, we want to see the next minimum weight. First, we have taken 1 and the next minimum edge weight is 2. But you have two edges in minimum weight 2. You want to write the between A to B vertices, the weight is 2 and A to C vertices, the weight is 2. From these two weight, We have to insert the column and we have to write it in the table as for AB vertices you want to write 2 and for AC vertices you want to write 2. Again, next minimum weight is 3 and 5. For C2D, the edge is 3 and for B2D, the edge is 5. You have totally 5 edges. First, you want to note down in all the tabular column. First, you need to note down this all the tabular column. Uh, Next, suppose, consider in this case DC has minimum weight, so we will select it. But now look at the graph and find the edge of next minimum edge. In case the edge BD has minimum weight, so we will select it. But in the next slide, I have explained that consider in our graph we have 4 vertices and minimum spanning tree will have three edges. We know one is the smallest weight, we are going to select the edge BC. Next, we have two weight. I mean, you have for AB vertices, you have 2 and AC vertices is also have 2. Based on this, you are going to select 2 edges. So 2 is the next smallest weight and edge AB does not form the circuit with the previously selected edge. So we will select it. Consider initially you have selected B and C with the weight of 1. Same way, you have 2 more vertices AB and AC. They both have the weight edge of 2. So you want to select it, right. So consider we are going to take the edge AB. So if you connect AB with BC, it doesn't form any circuit. So we are going to select that edge. Next edge, suppose again 2 is the smallest weight, but if we select the edge AC, that it will form a circuit. I have shown in the picture. See, if we connect with A and C, it will form 2. So it will form the circuit or loop. So we are going to reject this edge AC. So remember, in minimum spanning tree, we need to take the minimal edge, but it should not form any circuit or loop. That is the major point in Kruskal algorithms. Next, we need to select the next edge. In the H and Y tabular column, we have taken BC, then we have taken the vertices AB and rejected the vertices AC because it forms a circuit. So we have rejected that. And next edge is DC. And in next edge DC, sorry, I have wrote a mistake there. The DC weight is 3, not 2. So suppose if we take the vertices from D to C, it has the minimum weight 3. Now we have the option that whether we need to select the edge or not. But 3 is the next smallest weight. The DC doesn't form any circuit. So we are going to select that edge. So we can map from D to C. We have rejected one edge AC. Now DC is selected. Then one more edge and weight is there. That is BD and with weight edge of 5. Now it is shown in the next slide. Since we have got 3 edge, so we are going to stop here because you have 4 vertices and in minimal spanning tree there is one formula V minus 1. So V minus 1 means 4 minus 1. Actually, you want to have 3 edges. So totally 4 vertices is there and we have found out that 3 edges. Or suppose if you're taking the BD vertices, if you're connecting BD means definitely it will form a circuit between BC, DC and BD. So we are going to reject that edge. So mainly we have 4 vertices and V minus 1 edges. So totally 4 minus 1, 3 edges can be satisfied by using the Kruskal's algorithm. Actually, we need to work out for more problems in Kruskal's algorithm, but we have many types of algorithm in data structures. Actually, it is very easiest algorithm based on the minimum weight edge and it should not form any circuit. Only based on these 2 points, we are working out of minimal spanning tree. So this is the solution. So you can work out for any other problem easily. And one more thing you want to remember that in solution, you want to see calculate how many vertices are there, but the edge should be minimum. -1 should be edges should be there. Thank you. So you can ask any other questions again.